is the lesson for Chapter 7, Section 8, titled Geometric Sequences. Let's take a look at our first type problem that we'll end up seeing on the homework. It says, find the common ratio for the geometric sequence. So geometric sequences have common ratios, just as arithmetic sequences have common differences. So what we need to do is find out how are they going from 1 to 6, 6 to 36, and 36 to 216. Well, what they're doing is they are multiplying by 6 each time. You can see that when we go ahead and multiply 1 by 6, 6 by 36, and 36 by 6, makes that final 216. So the common ratio, which we're going to use a variable, we'll use r equals 6, and that would be it. So another way to do it, again, you could think of negative 2 times what makes 4, and that would be negative 2. But if you weren't sure, timesing by negative 2 does work out, you could always divide. You could divide 4 into negative 2 and see what that ends up being. You always divide the one that comes after into the one that comes first, and that also gives you that answer. And you can see how it works out. 4 times negative 2 makes the negative 8, and negative 8 times by negative 2 gives me positive 16. So yes, the r value, their common ratio, is negative 2. So I'll use that next method on this one, the fraction method. You just divide the second one by the first one. And when we go ahead and do that, we end up getting 1/2. So when the numbers are getting smaller, they are multiplying by a fraction, and the fraction is what you want to show. You don't show divide by 2, we show it as a fraction. And you can see how it works out. See, if you take the next one, 32, and divide it by 64, you also get 1/2. If you take the 16 divided by 32, that also makes 1/2. So the common ratio is 1/2. So this is very similar. Geometric sequences are just like the growth and decay problem. And here's an example that they ended up showing on the first part of Chapter 7, Section 8. Talked about imagine working part-time in a clothing store. Each week the coat doesn't sell. Its price is marked down 20%. What will the sale price for the coat be? Showing it right after 3 weeks. And so if this is a decay problem. And what we could end up doing is, since it's exponential decay, because things are being multiplied, we've got that common ratio. And so what we ended up using is this. We had y equals a times by b to the x power. And we said that a was the initial amount, $80, multiplied by b. What is the changing amount? Well, what is it going down by? We took that 20%, since it's going down by 20%. We rewrote that as 1 minus 0.2, and we found that was 0.8. And so that's what we're multiplying by each time, 0.8. And then we wanted to know, well, after 3 weeks, x is the number of weeks. And so we did the work. And this ended up being 0.512 multiplied by 80. And here's what we ended up coming up with. So 80 times by 0.512 gives us $40.96. So 40.96. Well, that's what we ended up doing in the last section, and you can always solve it that way. But what we're moving into is, in geometric sequences, we use explicit formulas. And so let's take a look at that, because that's going to be our next formula that we're going to end up having to use. So the explicit formula is basically the same as what we ended up doing here. They just write it a little bit different. Instead of y, they use a of n. And it equals, and then we have a1 multiplied by, so the first term, this is the initial value, just like a was the initial value here, multiplied by r to the n minus 1. So they use the common ratio, and that's what this b stands for, the common difference here in this case, or the value that it's being multiplied by each time, but they show n minus 1. And so what the difference here is that since they say after 3 weeks, in the explicit formula, they're going to use, for after 3 weeks, would be A4. And so that's the week after 3 weeks. And so it's the exact same thing, though. You end up getting the same answer, and you should shouldn't get a different answer for the same problem, just a different formula. And so they do 4 minus 1, and that gives us the same exact answer here. So R again was 0.85, I should show in that, and actually 0.8 because it went down by 20%. So let me fix that. Oops. So it's 0.8, and then we have to the third power. So you can see how you're going to end up getting that same exact answer. So the difference here between the explicit formula and exponential decay or growth is that when they're talking about after a certain amount of time, in the explicit formula, they always go with the next number higher. So they used week 4 to represent this problem. And so that's the difference here. So we're going to use this explicit formula in the next few problems. So let's take a look at the next one here. And so here it says write an explicit formula for each geometric sequence. So remember, the explicit formula goes this way. AN equals, and then we have A1, so the first one, the initial value, times by R to the n minus 1. So the first thing to do is find out what R is, the common difference. And so let's go ahead and do the work. 15 over 3, so I'm getting 5. It looks like, actually 15 over 5, I should say. So let's fix that one more time. 15 over 5 equals 3. So let's check and see if that works with all of them. 45 over 15 makes 3. 135 over 45, yeah, that makes 3. So it looks like the common ratio is 3. So to write the formula, we just write AN equals the first one, the initial value 5 times by the common ratio 3 to the n minus 1. That's it. That's all you have to do. And so on the next one, so I know this is a geometric sequence, they tell me, so let's go ahead and check out what that ratio is. You divide the second into the first, that gives me 6, and you can check to see if they all work. See, negative 72 over negative 12, yeah, that makes 6. Negative 432 over negative 72, try it out, should make 6. And so I know the common ratio is 6. I know the first number, the initial value, is right here. That's negative 2. So my formula would be AN equals the initial value, negative 2, times by the common ratio to the n minus 1. So again, this next one, same sort of thing. You can just divide. 500 into 100 goes 1/5 of a time. So you can see that works with all of them. Say 20 over 100 is 1/5. And 4 over 20 will also reduce to 1/5. So you can see how the common ratio is 1/5. So if the number is getting smaller, your common ratio is going to be a fraction. So our first initial value was a 1, which is 500. So we take that A of n, whichever value they decide to pick, and then we have 500 times by 1/5 raised to the n minus 1. So you can see that when we're dealing with the explicit formula, we are trying to find the nth term. So used, I guess we'll say used when finding the nth term. So whatever term they want to find, if they want to find the 100th term, you put 100 in for n, subtract 1, then do the calculation. Let's take a look at the last one here. 15 over 75, just reduce the fraction. I see 15 goes into all these numbers. Actually, I'll start with 5, actually, I'll start with and just see what happens here. So this is 3, and that ends up going 25 times. Actually, not 25, but that would be 2, so it would be 1 15 times, so it is. That is 1/5, and so let's go ahead and check the others real quick. So I have 3 over 15, yes, that makes 1/5, and checking this last one, I'm dividing 3/5 by 3, and so whenever you do that, basically when you've got a fraction over a fraction, this number is just going to go down below, and you end up multiplying 3 times 5, and that makes 3/15, which makes 1/5. So I know 1/5 is the common ratio. I know A1 is 75, and so I write the explicit formula. AN equals the first term, the initial value, 75 times by 1/5, all raised to the n minus 1 power. So the next type of problem that you see says write the recursive formula. Recursive formula is used when finding the next term. Finding the next term. And so what you're going to end up doing first is we're going to look for, we're going to write down at least what the first term is. So A1 equals just the first term. In this case, A1 would end up equaling 5. And so from there, we're going to end up writing AN. I'll write down the initial term. And then AN is the one that you're looking for, and that is just going to end up being A to the n minus 1, so the one prior times by R. And that's going to end up giving us our next, or recursive formula. So we just need to first find the common difference. And so they always like to specify what the first term is, just so we know, and then we can find other terms from there. So we'll go ahead and find that common ratio real quick. So negative 20 over 5 will give us what that is, negative 4. And I can see that when I divide each time, I do get negative 4. So negative 4 is the R value, the common difference, and so our recursive formula we're going to say is A1 equals 5, and then we'll say comma, and then AN equals, and then we have the AN minus 1, and then times by negative 4, and that's it. So you got to specify your first value, and that way we can go ahead and at least know where we started, and then A of n, the next value, is just going to end up being the one prior times by negative 4 in this case, because that's what the R value was. So in the next one, we'll find the R value first. 14 over 7 makes 2. And I see that when I do the other division, I'm going to get the same values. So that's going to be my R value. The initial term was 7, and then the recursive formula is going to end up being the AN minus 1 times by 2. And that's all you do. So this next one, again, 512 over 1024 is going to give us a fraction, and we end up with 1/2 when we go ahead and reduce that fraction. And so I know what the first value is. So the first value is 1024, and then from there I can go ahead and do the recursive formula. So AN minus 1 equals, and then we have, let's go ahead and fix that real quick. So AN equals AN minus 1 times by the R value. And so what that does for us, the recursive formula gives us the first value, where to start, and then we can find any value after that in this preceding value, as long as we know what the initial one was, and then the ones before it. And so we do the same thing over here. We divide negative 135 over 45, and when we do that division, we end up getting 3. And so this is going to end up being a negative 3, so we have one negative, and if we check the other one real quick, we'll do a 405 divided by 135, and that gives me the same value, so 3. So I'm pretty confident it's negative 3, and so I'm going to use the initial value was 45, and the recursive formula is AN equals AN minus 1 times by negative 3, and that is going to be our answer. So let's take a look at the last type of problem that we'll end up seeing, and here it says determine if each sequence is a geometric sequence. If it is, find the common ratio and write the explicit and recursive formulas. So best thing to do is check all the terms. So on the other problems, notice that they all said for each geometric sequence. So we knew they were geometric sequences, but now we have to determine whether they are or not. So we have to go through all the parts. And so let's do the division. 25 over 3. So everything should reduce down to 25 over 3 to see if it's a geometric sequence. So when I look at the next one, 50 over 25 makes 2. See how these numbers are not equal? Since they're not equal, that means this is not, or there's no common ratio. No common ratio, therefore it is not a geometric sequence. So let's take a look at the next one. Here we'll do negative 3 over 3 makes negative 1, but check the others. Make sure they're all negative 1. 3 over negative 3, yep, that's negative 1. The last one is as well. Negative 3 over 3 makes negative 1. So I know my common ratio is negative 1, so they want the explicit formula. So A, and then this would be N equals, and then my first value, which is 3, and then I multiply by the common ratio, negative 1, and then raised to the n minus 1 power. So that's the explicit formula. And then the recursive formula would be an equals, and then I've got, actually let's go ahead and write the initial value first. So a1 equals 3, and then an equals a to the n minus 1 times by r, which is negative 1. So those are the two parts there, recursive and explicit. So here it says to identify whether it's arithmetic, geometric, or neither. Now arithmetic means that it has a common difference. And with the geometric, again, we're looking for that common ratio. And if it's neither, if it doesn't have either one, then it's going to end up being neither. So let's take a look at our problems here. So you're looking at it 5 to 6. Okay, they're subtracting 1. 6 minus 5 makes 1. So far it's 1, but then 8 minus 6 is 2, and 11 minus 8 is 3. So you can see it's not arithmetic. And we'll take a look at if it's geometric or not. 6 over 5. And that should equal 8 over 6. And you see they do not equal. So if I reduce this fraction, divide it by 2, I get something that's not the same as the one prior. So this is neither geometric nor arithmetic. On the next one, we look at the numbers, and how do we go from 1 to 1/2? Well, 1/2 divided by 1 is just 1/2. So everything should have a ratio of 1/2. See, if you multiply by 1/2, 1/2 times by 1/2 is 1/4. Yes, this works. And then times by 1/2 again makes 1/8. 1/4 times by 1/2 makes 1/8. So yes, this is geometric. Because it has a common ratio. And the last one here, it says 1 to 4. So I'm going to subtract first. 4 minus 1 makes 3. 7 minus 4 makes 3. And 10 minus 7 makes 3. So you see how you have a common difference. So we would say it's arithmetic. Due to the common difference. So those are the types of problems that you're going to see on tonight's homework. Good luck.